Hey everybody. Today we're going to talk about multiplicity and graphing polynomial functions. We're going to start with a few concepts that we already know about, such as finding the zeros of a function, what end behavior is, what a y-intercept is, but we're also going to talk about this idea of multiplicity. So multiplicity is how many times does our root count as a factor of our polynomial. So let's go ahead and look at some examples. I have some graphs down here. We're going to label the degree of each polynomial and then state how many turning points that we have. So looking at this polynomial, looking at my picture here, I know that this is a quadratic function for a whole lot of reasons. I know that it makes a U shape when I graph it. And I know here they give us the equation here, x minus 1. 1 is my exponent there. And x plus 5, 1 is my understood exponent here. So I know that my degree of this polynomial is 2. How many turning points that I have? Turning points are how many times it changes directions. There's only one, and that's this point up here. So there's only one turning point up here. So that's 1. Now, other things that I want to make sure we point out, since I am going to be showing you what multiplicity is, notice this is where it crosses the x-axis at this point right here. And notice it crosses over here as well. Both of these points go through the x-axis. And what I mean through that is my function, it passes through the x-axis, and here it passes through the x-axis. In just a minute, I'll show you one that bounces off of the x-axis. So this one, we say it passes through or it crosses, and this one passes through and it crosses. So let's move to the next one. Okay. The second one is a cubic function, so I know that for a few different ways. My understood exponent up here, even though I don't see it, so I wrote those in pen. Even though I don't see the exponent up there, I know that it's understood exponent of 1, so it crosses 3 times. So I have 3. My degree is 3. I also know my number of turning points. There's one turning point down here, and then there's another turning point up here. So there are 2 turning points, 2 times where it changes directions. All of these roots and zeros cross through the x-axis. So this one passes through, keeps on going. This one passes through, keeps on going. And then this one passes through and it keeps on going. The next one that we do, there's going to be one that's the opposite of this. But for right now, everything that we're seeing is passing through the x-axis and it keeps right on going. I do want to take a minute just to recap end behavior. My first example here with my polynomial, both of these end behavior was negative infinity because it's going down. So it's going down on the left-hand side, negative infinity, and it's going down on the right-hand side. So end behavior for the first one was negative infinity. If I look here on the left-hand side, well, this is the left side of my graph. This function is going up. So my end behavior here is positive infinity. And my end behavior down here is going down, so this one is negative infinity. So just tying some things together that we've been talking about over the past several days. Now, let me look at example number 3. This is 3, and this is 4. So if I look at example 3, okay, now I want to show you what I mean as bounce as opposed to bounce and passes through. So let me highlight my roots. These 2 roots cross and they pass through the x-axis. So I'm going to say that this one crosses and this one crosses. This one is different. This one just bounces. And what I mean by that, think of like bouncing a basketball. You pass it, it just touches the x-axis. It doesn't go through it, and then it goes back down. So as opposed to this one that passes through the x-axis, it crosses through the x-axis, this one only bounces. So it only touches and then goes the other direction. It does not go through the x-axis. So we say that this one bounces. So that is a bounce. I still can find my degree. So my understood exponent here for these 2 equations, this one's 1 and this one's 1. So I can add up my exponents. So this is 1, 2, 3, 4. So my degree of this polynomial is 4. How many turning points do I have? Well, there's a turning point there, there's a turning point there, and there's a turning point there. So there are 3 turning points. And this is a quartic function. It goes 1, 2, 3, 4. And number 4, both of these are what we call bounce. They bounce through the x-axis. Or not through, I shouldn't say through at all. They just bounce to the x-axis. So this one goes up, it bounces, it changes directions. This one goes up, it bounces, it changes direction. It does not pass through the x-axis like this one over here. So this one goes up and through the x-axis, and this one bounces, and this one bounces. So those are called bounce. And this one bounces. Now let's say our degree and number of turning points. There are 1, 2, 3, 4. I'm adding here, so there are 4. That's my degree. And my number of turning points, I can see that from the graph, 1, 2, 3. Now, multiplicity is how many times does our root count as a factor of the polynomial. So if I look at y equals negative x plus 2 squared plus times x minus 3 squared, this one has a multiplicity of 2. The exponent tells me that. And this one also has a multiplicity of 2. The exponent tells me that. This one bounced through at negative 2. And this one bounced 2 at positive 3. If I look over here, if I look at my multiplicity, this has a multiplicity of 1. This one has a multiplicity of 2. And this one has a multiplicity of 1. So the exponent lets you know what the multiplicity will be. This one was 2, this one's 2, this one's 2. The other ones were just 1. If you have an even multiplicity, it's going to bounce through. So here, the x plus 2 squared corresponds to the negative 2. So notice it just bounced. If I take a look at the x plus 1, for example, number 3, this x plus 1 means it's going to cross at negative 1. And notice it crossed through because 1 is an odd number. But we're going to do some more examples in this video if that is kind of throwing you off. So multiplicity is how many times our factor counts. And most of the time the exponent will give you like a little hint. So let's definitely try some more. Definitely. So I got 4 examples here. Let's try to look at 2 at a time. So this would be number 1, 2, 3, 4. So right now, we're just going to identify what the multiplicity is and if it crosses or bounces. So if I look here, I'm going to highlight my roots. 2 of these roots bounce. This one bounces and this one bounces. So it touches the x-axis and then it goes the other direction. So think of a basketball touching the floor and then coming right back up. This one crosses through the x-axis. It keeps right on going and it passes through. So we will label these 2 as bounce. So these 2 are bounce. And we will label this one as crossing or passing through. So if you said it crossed through the x-axis or passed through the x-axis, that's the same thing. So it crosses or passes through. These bounce. And another word you might also hear is touch. So they only touch the x-axis. They only bounce to the x-axis. As far as multiplicity goes, x plus 1 has a multiplicity of 2. X minus 2 has a multiplicity of 2. And 2x minus 1 has a multiplicity of 1. So if I were to set this equal to 0, x plus 1 equals 0. So negative 1 would be the root. So it corresponds to negative 1 up here where my finger is. This one here, x minus 2, set it equal to 0. It's going to cross at positive 2. Notice it bounces through right there. So your even numbers are going to bounce and your odd numbers are going to cross through. Let's take a look at 2 more. Again, I can see my roots and my zeros here. This one bounces. Hopefully you see it goes up, it touches, it comes right back down. So this one bounces. This one crosses through, passes through the x-axis. It keeps right on going. So this one crosses. X plus 1 squared has a multiplicity of 2. So that means that factor counts twice. X minus 3 to the third has a multiplicity of 3, so that means that factor counts 3 times. If it's odd, like the number 3 down here where my pen is, if it's odd, it's going to cross through. Notice it crosses through. If it's even, notice this 2 here is only going to bounce. Notice it bounces up here. And the last one I want to take a look at before we get into what you should be expected to know on your assignment today, let's label number 3 and kind of see what's happening here. So if I look at number 3, I see a combination of some different things. I see that this root over here crosses. I see that this root here, so this one crosses. It goes right on, passes through the x-axis. This one only bounces. It touches the x-axis. So that's a bounce. And this one here crosses. So x plus 1 corresponds to -1. You take the opposite sign, you solve it. Notice that one crossed, and it has a multiplicity of 3. This x minus 2 is squared, so it touches right here. That's an even number, so it bounces. And this one here, this x minus 4 crosses through. So it goes up and it goes through the x-axis. So now we know the difference between bouncing and crossing, so we can get into some examples on what you should be expected to know.